Welcome to The Explainer. Today, we're diving into the hidden, dual-track science of how your favorite apps actually make it onto your screen. Have you ever stopped to think about what happens in that literal blink of an eye when you tap an icon on your phone? Behind that single tap, there is an absolute battleground. Developers are fighting for mere milliseconds, while designers are actively hacking human psychology to make you feel like things are moving way faster than they actually are. It's this incredible intersection of hard computer science and cognitive psychology. So let's get into it. Here is our roadmap for today. We'll cover the 3-second death trap, the anatomy of app starts, the millisecond war, the psychology of waiting, and finally, hacking time with skeletons. Section 1, the 3-second death trap, or why slow apps die. Because let's face it, speed isn't just some nice-to-have luxury anymore, right? It's the absolute baseline. If your app is slow, you aren't just annoying your users, you're losing them completely. And the penalty for being slow? It's honestly catastrophic. Get this, 88% of users will flat out abandon an app just because of slow performance. That's almost everybody. And it gets worse. Just a single 1-second delay causes a 7% drop in conversions. If an app takes longer than 6 seconds to load, you're looking at a 33% higher uninstall rate. Startup performance is not just some vanity metric for developers to brag about, it's the very first impression your product makes. If that first frame is slow, your users are definitely not sticking around to admire your brilliant code architecture. They just bounce. Think about your own habits for a second. You tap an app, and nothing happens. No UI, no little loading circle, just a totally blank screen. What do? Well, 3 seconds later, you've probably already assumed the app is completely frozen and you force quit it. We've literally all experienced this kind of app rage, and trust me, your users are doing the exact same thing. Section 2, anatomy of app starts, cold, warm, and hot. To actually fix this dropping user rate, we have to look under the hood. What's happening inside your phone when you hit that icon? Well, it turns out not all app launches are created equal. A hot start is the one we all absolutely love. The app is already hanging out in memory, running in the background, and the system just pops it back to the foreground. Boom, instant. But a cold start? Man, that is the grueling, heavy lifting. A cold start means the app's process literally doesn't exist yet. The operating system has to build the whole thing from absolute scratch. It's the slowest, most resource-heavy scenario. And here's the kicker. It's exactly what users experience the very first time they open your app. Oh, and sitting right between those two is the warm start, where the app has some data saved but still has to rebuild the screen. So during that heavy cold start, the system and your app have this massive to-do list to get through. First, the system loads and launches the app, pops up a blank starting window, and creates the app process. Then your app finally takes the wheel. It has to launch what's called the main thread, inflate the views, which basically means translating code into the actual visual buttons and text you see, lay out the screen, and finally execute the initial draw. The absolute biggest bottleneck here? Step 3, the main thread. Think of the main thread like a sacred single-lane highway that's only meant for drawing the user interface. If you jam it up with heavy initialization tasks, database queries, or network calls, the system physically cannot draw the screen, so the user is left staring at absolutely nothing. Moving to Section 3, the millisecond war, measuring startup success. Because the stakes are so incredibly high, developers are essentially fighting a microscopic war. And as the saying goes, you can't manage what you don't measure. You really need to understand your metrics here. First up is TTID, or time to initial display. This is exactly what it sounds like, the time it takes to show the very first frame of the app. If your TTID is dragging, the app feels completely broken, even if the rest of the data is loading lightning fast in the background. It is absolutely your ultimate first impression metric. Right on its heels is TTFD, time to fully drawn. This is the magic moment when the user can actually start tapping around and engaging with the fully loaded app. They're both super important. Basically, TFID tells the user, hey, I'm working on it, while TTFD tells them, okay, I'm ready to go. And you know who cares about this even more than your users? The platforms themselves. Google actively tracks startup times using Android Vitals, and they will straight up penalize your app in the Play Store if you cross certain thresholds. If your cold start takes 5 seconds or a warm start takes 2 seconds, your app's discoverability is going to tank. Apple is right there too. They actually recommend that your very first frame appears in under 400 milliseconds. That is incredibly fast. To win this crazy millisecond war, developers use some very specific battle tactics. The golden rule: do way less work before drawing that first frame. You've got to defer non-critical initialization, stuff like analytics or crash reporting, until after the screen is visible. Just wait on it. You also need to offload heavy database reads to background threads, so you keep that main thread wide open. Oh, and if you're on Android, you can use baseline profiles, which basically pre-compiles your code so it executes up to 30% faster from the very first launch. Huge game changer.
Section 4. The psychology of waiting. Fixing the human, not just the code. Now, what if I told you that you could optimize your code flawlessly, hit all those metrics, and it still might not be enough? Because at the end of the day, you aren't just managing RAM and CPU cycles. You are managing a human being's perception of time.
And this is where we pivot from hard computer science to cognitive psychology. Back in 1985, an expert named David Meister published this really seminal paper on the psychology of waiting lines. His core takeaway was so simple but profound. Occupied time feels shorter than unoccupied time. When people have literally nothing to do, every single second drags on forever. Standing in a boring blank hallway feels endless, right? Well, staring at a blank screen in your phone triggers that exact same psychological anxiety.
Meister boiled this down into a brilliant little equation. Satisfaction equals perception minus expectation, which basically means that user satisfaction is driven by how long the wait feels, which drives a massive 72% of queue satisfaction rather than what the actual stopwatch says. So a customer who waits 10 minutes with zero information feels like they've been waiting 20. But a customer waiting 15 minutes who gets constant updates, they feel like it's only been 10. It's all in our heads.
He outlined a few specific laws for how our brains work here. First, pre-process waits feel way longer than in-process waits. If an app just hands you a blank screen, you're stuck in a pre-process wait. You haven't even started yet. But if it shows you a basic layout, boom, you feel like the service has begun. Second, uncertain waits are just pure agony. Not knowing if the app has totally crashed or is just thinking creates massive anxiety, and anxiety magnifies every single moment. Our main goal in app design is to kill that anxiety and give the user's mind something to chew on.
Which leads us perfectly into Section 5, Hacking Time with Skeletons, the ultimate UX weapon. This is the crown jewel of modern app design when it comes to managing that wait anxiety and totally hacking your perception of time.
Let's put the two heavyweights in the ring together. On one side, we have the classic loading spinner. This gives us what we call activity feedback. It tells you, hey, I'm doing something, but gives you zero actual context. It creates a high cognitive load because you're literally just watching a circle spin and focusing on time passing. On the flip side, we have the skeleton screen. This provides information feedback. It shows you the exact shape of the upcoming page before any of the real data even arrives. It just feels vastly faster and way more responsive.
Here is exactly what a skeleton screen is doing. By rendering this lightweight wireframe, usually those gray blocks with that subtle little shimmer animation, it completely shifts your brain from passively waiting to actively anticipating. Your brain instantly starts processing the layout. Okay, there's the profile picture over there, and there's a huge block of text right there. This tiny bit of mental engagement occupies your time. The actual stopwatch time to load the app might be exactly the same as the spinner, but your brain perceives it as significantly faster.
But if you're going to use skeleton screens, you have to do it right. Best practices are absolutely crucial here. First off, your gray placeholders have to match the real layout perfectly. If they don't, the moment the real data loads, the elements are going to jump all over the screen. That's called cumulative layout shift, and it is incredibly jarring for the user. Also, you definitely want to include some subtle motion, like a pulse or shimmer, just to prove the app hasn't frozen. Use these mostly for content-heavy stuff, like your social feeds or dashboards. You definitely wouldn't use a full skeleton screen for a tiny submit button. A little spinner works totally fine for that quick activity feedback. Okay, I've got one more amazing psychological hack for you, specifically for when you absolutely must show a progress bar. It's called the asymptotic progress pattern. You've probably seen it at the top of YouTube. Honestly, this progress bar is lying to you, but it's lying to make you feel better. What it does is shoot up incredibly fast to like 40 or 60%, instantly reassuring you that, wow, rapid progress is happening. But then it gradually slows down, creeping closer and closer to 100% without ever actually stopping, until the task finishes and it snaps all the way to completion. It front-loads the visual progress to crush your wait anxiety. It's brilliant.
So what does this all mean? Well, building a lightning-fast digital experience means you really need a dual-track mindset. You absolutely must optimize your cold starts, defer those non-essential initializations, and keep that main thread clear. But remember, humans are not stopwatches. So I'll leave you with this provocative thought. As you're building or using these digital products, are you just optimizing the code, or are you also actively optimizing the user's perception of time? Thank you so much for joining me for this explainer, and I'll see you next time.